Welcome back to channel and back to the tutorial for machine learning. Today I'm going to see the algorithm called linear regression in machine learning. So one of the important algorithm. Let's go for discussion today. Discuss about when you like the channel, please subscribe and share with your friends. And so as of you know, what is regression? You can say it's a supervised learning technique that supports finding the correlation among the variables. Let's go for find options. And moreover, with the help of regression, we can plot a graph between the variables which best fit the given data points here. There are types of regression models like linear regression, polynomial, at last logistics. We are going to see if the logistics also available. We are going to see about only the linear regression here. So linear regression, as of now, is one of the familiar algorithm where show the linear relationship between the independent variable x-axis and the dependent variable y-axis, consequently called the linear regression here. Moreover, if there is a single input variable, such the linear expression is called simple linear, and if there is more than one input variable, let's highlight the point here. If you have more than one input variable, that is called as multiple linear regression here. Moreover, the model always gives a sloped straight line describing the relation between the variables here. So let's go for the graph. The graph going to display the linear relation between the independent variable and the independent variables. Let's go for the graph here. See, this is a graph where showing the independent variable and dependent variable. See, nearby, showing the things here. Here, when the value of x is increases, the value of y is likewise increasing also. Then, to calculate the best fit line linear regression, we can use the traditional slope intercept form that is called y is equal to mx plus b. It implies y is equal to a naught plus a1x here. Then what stands for here? Y stands for independent variable and x stands for independent variable and a naught stands for intercept of line and a1 for the linear regression coefficient here. And here, example, how can say example? Here we can understand we can get something from the simple example that's called we can estimate the salary of an employee based on an year of experience. The recent company data which indicates the relationship between the experience and the salary. As of you know, the employee will get the more salary based on the experience only. Here, year of experience is an independent variable and salary of an employee is a dependent variable. Remember, as the salary of an employee is dependent on the experience of the employee here. Using the insight, we can predict the future salary of the employee based on the current and past information. Let's example the employee having 5 years experience. The value of the salary will be more and more than 10 years means more we can say more and more. And a regression line can be a positive linear or negative linear. Let's see the plot diagrams here. Here, first of all, positive linear relationship. Here, if the dependent variable expands on the y-axis, see, if the dependent variable what happen? Expand the y-axis, and the independent variable progress on x-axis like this, what will happen? Then such a relationship is termed as a positive relationship here. Y towards y increasing, and x towards like this. So showing the plot diagram. Negative, then negative linear regression. Negative linear relationship is nothing but if the dependent variable decreases on the y-axis and the independent variable increases on the x-axis, such a relationship is called a negative linear relationship. That is called opposite of the positive linear relationship. Let's go for some of the terms where it will be things will be associated with the linear regression. That is called one is called finding the best fit line. So how do you find the best fit line with the help of this linear regression? So when working with the linear regression, our main goal is what? To find the best fit line. That means the error between the predicted values and the actual values should be minimized. So it have the least error. So what is the concept here? We can predict the value and actual value should be minimized here. And the different values of the weights are the coefficient line of A0, A1 gives a different line of regression here. So we have to calculate the best value of our A0 and A1 to find the best line. So we have to calculate the cost function. So remember, so cost function is the one of the important term when you come for the linear regression. We have see the only basic here and cost. So here total n is equal to stands for total number of observation, y is equal to actual value, and a1 xi plus a0 is equal to predicted value here. Just now we discussed the terms like what is the predicted values plus the actual values. And residuals. Here, the distance between the actual value and the predicted value is called as a residual as per the terms of machine learning here. And if observed points are far from the regression line, then what happens? The residual will be high. and so cost function also automatically become high here. If the scatter points are close to the regression line, then the residual value will be small, and hence the cost function it changes here. Cost function. So this is a simple diagram where showing the cost function consists of error, independent variable associated with slope. Y is stands for intercept and dependent variable here. Here the dependent variable that is to be predicted as denoted by the y. A line that touches the y-axis is that is denoted by the intercept b naught here. And b1 is the slope of the line where x represents the independent variables that determine the prediction of the y here. Let's see the diagram, dependent variable and everything. We can understand the cost function here. The error in the result predictions denoted by the term called E, and the cost function provides the best possible values for B naught and B1 to make the best fit line for the data points here. So like that we can minimize the errors as we discussed now. That is between the actual value and the predetermined value. Then go for formula. So minimize 1 by n sigma I is equal to 1 to n is a limit where you have prediction minus yi whole square. Then another formula you have j is equal to 1 by n sigma I is equal to 1 to n prediction minus ya square. This is a formula where you can use for determining the cost function properly. Then we have one more last one that's called gradient descent. This is nothing but one of the important terminology where you can understand about the linear regression called the gradient descent. It's a what is this gradient descent? It is a method of updating B0 and B1 values to the reduced MSC here. The idea behind is simple. Let's keep iterating the B0 and B1 values until we reduce the MSC to the minimum here. At last, we can update the B0, B1. We can take gradients from the cost function to find these gradients, and we can take partial derivatives with respect to the B0 and B1. These partial derivatives are the gradients and are to use the update the values of B0 and B1. So we are going to a simple graph. The upcoming session, whenever possible, go for practical implementing the Python also. Let's see the diagram where you can get clarity. This is the about the help of the generated help of gradient descent. That is called one is called big learning rate, another called small learning rate. It comes small learning rate. This small learning rate, big learning rate comes up like this. So I hope that you understand about something about what is linear regression and how it is for the machine learning like that. If you have any queries or suggestions, please kindly comment with the social media. And thank you for watching the video.